Good day everyone. Let's talk about convection heat transfer. We have already seen a type of heat transfer where the molecules transfer heat due to random vibrations and collisions. But if you observe very carefully, the third molecule only gets the energy if the second molecule gets the energy. It is not possible for the third molecule to directly bypass the second molecule and get energy from the source. But what if it could happen? This can only happen when the third molecule is in motion and comes in contact with the first molecule on its own. So, this type of energy transfer, where the molecules have motion, but more importantly have a directional motion towards the source and attain energy from the source, is called convection. This type of energy transfer is mainly seen between the layers of solid surface and adjacent liquid or gas. The faster the motion of the fluid, the greater is the convection heat transfer. So convection heat transfer is a combination of both conduction and fluid motion. That is, if fluid motion is absent, then convection becomes purely conduction. But the presence of fluid motion enhances the heat transfer, and so convection heat transfer is usually greater than conduction heat transfer. But the presence of bulk motion of the fluid also complicates the determination of heat transfer rates. Consider this example. There is a hot block present in wind of cool air. Energy is first transferred from the solid surface to the molecules which are exactly beside the solid surface. This happens only because of conduction. Then the other molecules sweep in and carry away the heat from there. This is bulk motion. So the overall transfer of energy from the solid surface to the adjacent fluid molecules due to conduction, and then the carrying away of heat from these adjacent molecules to the molecules that are in motion, all these effects combined is called convection. Of course, when molecules come in contact with the hotter ones and remove the heat, then colder molecules come into the same position in order to accept heat from the adjacent molecules and then transfer the heat away from the hot surface. Convection can be of two types: forced convection and natural or free convection. In forced convection, the flow of molecules is mainly because of an external source such as a fan or a pump or wind. In natural convection, the fluid motion is caused by buoyancy forces that are induced by density differences due to variation in the fluid temperature. In the absence of any external man-made forces, convection only happens due to natural or free convection. This happens when buoyancy forces are able to overcome the air resistance. But in case of forced convection, there is still a chance that some portion of convection is being contributed from natural or free convection. Despite its complexity, convection heat transfer can be estimated using a simple formula called Newton's law of cooling. According to this law, the rate of heat transfer is proportional to the temperature difference, and it is also proportional to the surface area from which heat transfer is occurring. So to avail some mathematical benefit, the proportionality has to be removed and a proportionality constant needs to be placed. This constant is called convection heat transfer coefficient. Unlike thermal conductivity, which is a property of the matter, convection heat transfer coefficient is not a property of a fluid. Of course, this proportionality constant depends on the materials involved, but it also depends on the geometry and the orientation of the surface. Take a look at these examples. In one of the cases, convection is well established, but in the other case, the source itself acts as an obstruction to the convection currents, which hinders the heat transfer. So, the convection heat transfer coefficient is not always constant and is experimentally determined.